Good morning, children. Nice to meet you again through this video. Turn to page 281. We have to do the numericals based on specific latent heat. Okay, we have not done the numericals based on specific latent heat. So today we'll be doing that. Okay, so before going into the numericals, let's quickly recollect the concept of latent heat. What is latent heat? The heat energy required to change the state of, okay, latent means hidden. So whenever there is a change in phase, a change of state or change of phase, during change of state or change of phase, there is no change in temperature. You know that? Okay, so that heat is called latent heat. Okay, and specific latent, so heat energy required to change the state of a substance. Okay, that is latent heat. So when I say specific latent heat, then it will be specific latent heat, then it will be equal to heat energy upon mass. Okay, so heat energy per unit mass. Total heat, generally latent heat means heat energy required to change the state of a entire mass. When I say specific latent heat, per unit mass. So it will be heat energy upon M. So from this I get the formula for heat energy as M into, so specific latent heat, usually we write it as L of ice. Okay, of ice, we are talking about ice. So heat energy will be M into L of ice. Heat energy is equal to M into L of ice. Okay, so this is the formula that we'll be using in the numerical. So during change of state, now during change of temperature, so whenever a body, in A part we saw a body undergoing a change in temperature. So during that time, heat energy liberated or absorbed will be mc del T. Okay, mass into specific heat capacity into change in temperature. Okay, into change in temperature. This is during change of state. The formula for heat energy absorbed or liberated will be M into L of ice. M into L of ice. Now del T won't be here. Del T won't be here because temperature is not going to change. During change of state, temperature is not going to change. It's going to remain constant. Okay. So, so before you start the numericals, I want you to note down like this formula. Okay, formulas that we will be using. First is during change in temperature, and then change of state. So during change in temperature, the formula we use is heat energy absorbed or given out is mc del T. So this will be specific heat capacity of that material. If it's water, then water. If it's copper, then C of copper we have to take. Now during change of heat, heat energy is M into L of ice. M into L of ice. Now C is specific heat capacity of that substance. And okay, this is specifically we are talking about water. So because we are talking about water frozen into ice. So what is the value of specific heat capacity of water here? 4.2 joule per gram degree Celsius. And L of ice is specific latent heat of ice. Specific latent heat of fusion of ice. Actually, it is such a long term. Specific latent heat of fusion of ice, and its value is 336 joule per gram. You know this value also. Specific latent heat of fusion of ice is 336 joule per gram. Means to melt 1 gram of ice, you need 336 joules of heat energy. Here, what is the meaning of this? To raise the temperature of 1 gram of water through 1 degree Celsius, you need to give 4.2 joules of heat energy. Okay, children. So these are the two formulas that we'll be using. Change in temperature means mc del T. Change of state means m into L of ice. You will be usually using ice melting to water or water freezing to ice. So these two values you're supposed to remember. Is it clear? Now we'll start with the numericals. First, I've started with very simple numericals. Okay. What is the heat energy required to do the following? Required for the following. 1 kg of ice at 0 degrees Celsius is heated till it becomes water at 20 degrees Celsius. 1 kg of ice at 0 is heated till it becomes water at 20 degrees Celsius. So, ice at 0 degrees Celsius has to become water at 20 degrees Celsius. Now, for this thing to happen, what all should happen? First, ice at 0 has to undergo change of state. It has to undergo freezing. It has to freeze. Okay. It has ice at 0 has to undergo melting to become water at 0 degrees Celsius. Okay. So you write water at 0 degrees Celsius. See children, I give you 1 kg of ice and you have to keep heating it till it becomes water at 20 degrees Celsius. Now what will happen? First the ice would have melted. Okay. So that's the first process. Ice at 0 has to melt to water at 0 degree Celsius. And what will be the formula for that? M into L of ice. Then this water at 0 has to undergo change in temperature from 0 degree Celsius to 20 degree Celsius. Water at 20 degree Celsius. Is it clear? So first will be melting. Second, so two things are involved. Melting and then, so the total heat energy required will be heat energy for melting of ice and plus heat energy for change in temperature. Change in temperature. So heat energy for melting of ice. So 1 kg of ice at 0 degrees Celsius. So formula will be M into L of ice plus M into C of water, because ice will change to water, into del T. Now M is 1 kg and L of ice is 336 into 10. Because it is in kg, you have to take 336 into 10 power 3. So 336000, okay, plus M into C of water, 1 kg into C of water 4200, because it is in kg. Again, it's not 4.2. I should take 4200 joule per kg per Kelvin into del T. It has to change from 0 degree Celsius to 20 degree Celsius. So 20 minus 0. The change in temperature will be 20 minus 0. Did you understand, children? So for this to happen, two processes should happen. First is melting, then change in temperature. So heat energy for melting, M into L of ice. Heat energy for change in temperature, M into C of water into del T. So this will be 336000 plus 4200 into 20. That will be 336000 plus 0, 0, 0, 2 2s are 4, 2 4s are 8. So 10 carry 1, 8, 9, 12, carry 1, 4. 4,20,000 joule is the answer. Hope you have understood this clearly. Okay, so this is how you calculate heat energy required for changing ice to water at 20 degrees Celsius. Okay, now see this numerical number 2. What is the heat energy given out? Now the reverse is happening. 600 gram of water at 50 degrees Celsius freezes to ice at 0 degree Celsius. So you have to remember this also, children. One more thing. When I say L of ice is 336 joule per gram, means when 1 gram of water freezes to ice. Okay, when 1 gram of water freezes to ice, it will take heat energy or give heat energy. It will give out. In a refrigerator, when you keep a thing, you're cooling it and the heat is given out. So heat energy given out will be 336 joule. Okay, L of ice, when I say 336 joule, means while freezing, every 1 gram will give out this much. And so if 1 gram of ice melts to water, it will take heat energy. Heat energy will be absorbed, and that is also equal to 336 joules of heat energy. Hope you are understanding. For 1 gram of water to freeze to ice, heat energy will be given out. 336 joules of heat energy will be given out. So L of ice, when I say, it will be the same for freezing as well as for melting. For freezing as well as for melting. Okay. Okay. So how much heat energy is given out when 600 gram of water? So 600 gram of water should freeze to ice at 0 degrees Celsius. Okay. What are the changes that has to happen? First, 600 gram of water at 50 degrees Celsius. Now, can water at 50 immediately freeze to ice? No. First, what should happen? Water at 50 degrees Celsius should come to 0 degrees Celsius. Okay. Water at 50 should change to 0 degree Celsius, for which change in temperature is happening here, and you will use the formula mc del T plus, can you understand, children? So your final destination, or finally it has to become ice at 0. Okay, so but directly water at 50 cannot freeze to ice. So first water at 50 has to come to water at 0. This is what will happen when you keep in a refrigerator. You keep water at 50 degrees Celsius. First it will come to 0 degree. Till that it will remain water. So it is only change in temperature. There is no change of state. Then what happens? Freezing happens. Okay, ice at 0 degree Celsius. This water at 0 becomes ice at 0 degree Celsius. And for that, we will be using M into L of ice. Hope you have understood. So, and in this, heat energy will be given out. Here, heat energy absorbed. Here, heat energy absorbed. Here, heat energy given out. For this entire process to happen, will be, first will be mc del T for change in temperature, plus for freezing I use the formula M into L of ice. Now mass is 600 gram. Okay, 600 gram. Because I have it in gram, I can take C of water as 4.2. This will be 4.2 because it is water, into del T will be 50 minus 0. It has to change from 50 to 0, plus M again is 600 and L of ice 336 joules per gram. Okay, so if I solve this, I will be getting 600 into 42 into 5 plus 600 into 336. Okay, so 600 into 42 into 5 will be 96,000. 600 into 336 will be this one. So if I add both, 0, 0, 6, 6 plus 1, 7, 9 and 2. So 2,97,600 joules of heat energy will be given out. When 600 gram of water, okay, you fill it from a tap on a hot summer day. Suppose imagine the temperature was 50 degrees Celsius. Okay, so you fill the water from a tap and you kept it in the fridge. And you want freezer and you wanted it to become ice at 0 degrees Celsius. And do you know how much heat energy it will give out? 2,97,600 joules. So that's why around a refrigerator, usually the sides of a refrigerator and all will be very hot. Why? The heat from inside, whatever you keep it inside, the heat will be given out because it is cooling and then freezing. So that is what. So this is how the numericals based on change of state and change of temperature will be involved. Okay, so these are two simple questions. You can please note down these two questions. It's not there in the book, but to understand the basics, I started with these two numericals. Now we'll go to the book numericals, and I'll be following a different order because the toughness levels are like different. So next I'll be doing in page 282 question number 10. Question number 10. Okay, calculate the total amount of heat energy required to convert 100 gram of ice at minus 10 degrees Celsius completely to water at 100 degrees Celsius. Okay, amount of heat energy required to convert 100 gram of ice at minus 10 to water at 100 degrees Celsius. Okay, so page 282, so page 282, numerical number 10. Okay, so calculate the amount of heat energy required to convert. So 100 gram of ice at minus 10 degrees Celsius has to become water at 100 degree Celsius. 100 gram of ice at minus 10 to water at 0. Now you have to understand that in the previous numerical when we did, there ice was at 0 degrees Celsius. So in the first numerical which we did, again in that ice is heated till it becomes water at 20 degrees Celsius. But here ice was already at 0 degrees Celsius. Okay, can you see the difference? Here, this numerical that we are going to do, ice is at minus 10 degrees Celsius. It is not at 0. It is at minus 10 degree Celsius. So one more step will be involved. Okay, so three things will be happening. First, ice at minus 10 degrees Celsius will become ice at 0. Can you understand? So when you keep a block of ice outside at minus 10, the block, maybe if you take a block of ice from refrigerator, maybe it is at minus 4 degrees Celsius, you leave it outside, it will stay as ice for some time till it reaches 0 degrees Celsius. Only then it starts melting. So same way, if you keep a block of ice outside or you heat it, it will remain as ice till 0 degrees Celsius. Then only it will start melting. So that is the first step. Ice at 0 has to change to ice at minus 10 has to change to ice at 0. So what is happening here? Change in temperature. Though it is involving ice, but there is no change of state. Ice at minus 10 has to change to ice at 0 degrees Celsius. Then the second one will be melting. Once it reaches 0 degrees Celsius, then if you heat further, it will start melting. That is the second thing. And the third thing, so now what you will get? Water at 0. After melting, you will have water at 0 degrees Celsius. But the conclusion they are saying, you should heat till water becomes 100 degrees Celsius. So water at 0 to water at 100 degree Celsius. Okay, this water at 0. Okay, so in melting, ice at 0 will change to water at 0, and then this water at 0 to water at 100 degrees Celsius, again change in temperature. Okay, 2 change in temperature and 1 melting. So the formula, so heat energy required will be for this m into C into del T. But remember, here you should write C of ice. It is not of water. The substance here is ice to ice. So you need C of ice, and C of ice value is different. It is not 4.2, it is not 336. C of ice is totally different. Okay, that is given in the book. In the question itself, they have given specific heat capacity of ice is 2.1 joule per gram. Specific latent heat of ice is 336. We all know that. There's another thing, specific heat capacity of ice. That means to rise the temperature of ice by 1 degree Celsius, you need to give 2.1 joules of heat energy. So m into C of ice into del T, and here it will be m into L of ice, and here again m into C of water. Here water at 0 has to change to water at 100 into change in temperature del T. I hope you're clear with this, children. For this, you have to take C of ice. For this change in temperature, you have to take C of water. Now all the values are given. You have to substitute. So 100 grams. So mass is 100 gram in all the three into C of ice, as I showed you, is 2.1 joule per gram per Kelvin. So 2.1 into what is del T, change in temperature? Ice has to change from -10 to 0. So change in temperature will be higher minus lower. This is higher and this is lower. Okay. So 0 minus of -10. Hope you're getting it. Higher temperature is 0. From 0, it has to come. Sorry. From -10, it has to reach 0. So change in temperature will be 0 minus, okay, final minus initial. So because the initial temperature is already in a minus, so you'll have minus of minus here, plus m into L of ice. M is again 100 into 336 plus again 100 into C of water is 4.2 into del T, change in temperature here 0 to 100. So 100 minus 0. So it will be 100 into 2.1 into 10. It will become positive. Minus into minus plus 10 plus 33600 plus 420 into 100. Okay, 100 into 4.2 is 420 into. So when I multiply this, I get and add this, I get 7,77,000 joules. 7,77,000 joules. In your book, it's given 7.77 into 10 power 4. Both are one and the same. Did you get it, children? So this involves 3 steps and you have to add all the 3. Okay. So these numericals are a little bit tough. So if you understand it, it should be. So first you write clearly what are the changes that has to take place. For this to change to this, there should be 3 steps happening. Write those 3 steps, then write the appropriate formula, then solve it. Is it clear, children? I hope you have understood. Now the homework for today will be, okay. Okay, we'll do one more sum. I'll do one more sum. Fourth numerical, page 281, question number 4. Page 281, question number 4. Okay, so this is also a refrigerator converts 100 gram of water at 20 degrees Celsius to ice at -10. Okay, so opposite of it. Here it was ice at -10 has to change to water. So you had to give heat. Here in a refrigerator, heat energy will be given out. Here it will be taken. Heat energy would have been absorbed. Here it will be given out. Okay. A refrigerator converts 100 gram of water at 20 to ice at -10. So 100 gram of water at 20 degrees Celsius to ice at -10 degree Celsius. And this is done in, okay. Now what are the steps involved, children? Calculate the specific, the specific heat capacity of water, specific latent heat of ice is given, and specific heat capacity. Okay. Calculate the average rate. If you see the question, calculate the average rate of heat extraction. So rate of heat extraction is basically power. They're asking you to find the power because you know the time. So you can find the heat energy from that, and you know the time. Therefore, you know you can find the power. Okay. So now see the question. 100 gram of water at 20 has to change to ice at -10. So what are the steps involved? Again, there will be 3 steps involved. What are they? First, 100 gram of water should change to 100 gram. Sorry, don't write that. Water at 0, water at 20 degrees Celsius to change to water at 0 degrees Celsius. Okay. It has to become water at 0, then only it can go to the second process, that is freezing. That is water at 0 has to change to ice at 0. And then again ice at 0 has to change to ice at -10 degree Celsius. Is it clear, children? So again, here it is change in temperature. Here it is freezing, change of state. Okay, freezing is happening here. And here again change in temperature. Hope you understood. Can you see the difference here? Here 100 gram of ice at -10 to water at 0. So ice at -10 to become ice at 0, then melting, then this. Whereas here you have water at 20 to change to ice at -10. So what will happen? Water at 20 to water at 0. Then it has to freeze. Then again the ice at 0. You would have got ice at 0. But they want ice at -10 degrees Celsius. So it has to change to ice at -10 degrees Celsius. Again there will be change in temperature. So again here, so this will be heat energy given out. So M into C into del T. Again here it will be C of water plus M into L of ice plus M into C of ice into del T. So mass of thing is 100 gram. C of water 4.2 and del T water at 20 to water at 20 to water at 0. Okay, so 20 minus 0. Then plus 100 into L of ice is 336 plus 100 into C of ice is 2.1 into again from 0 it has to go to -10. Okay, so 0 minus of -10. Okay, when it is fall in temperature, okay, here it is falling in temperature, so it will be initial minus final, okay, so this minus this. So there it was rise in temperature, therefore it is 100 minus 0. Here it is fall in temperature, therefore it is 20 minus 0. Okay, children, so if you solve it, okay, you can solve it and you'll get the value. And then if you so they have asked you to find the power. Okay, this value comes out to be 4000. So it is plus 33600 plus 100 into 2.1 into 10. Okay, so the answer comes out to be 44100 joule. Okay, then power is equal to heat energy upon time. So 44100 upon 73.5 should have been converted into seconds. So you should have multiplied it with 60. The answer will come out to be 10 watt. Hope you have understood these numericals. And then the homework for today will be numerical number 1, 2 and 11. Okay, homework 1, 2 and 11. Numericals 1, 2 and 11. Okay, if you have any doubt, I'll clarify it when we meet on Saturday. Thank you, children.